Good day. So, welcome sa next lesson natin, yung inverse nung exponential function na diniscuss natin last time. So, now we'll discuss the logarithmic function. Yung gusto nating matutunan today ay one, i-define natin kung ano ang logarithmic function. Pangalawa, i-evaluate natin yung logarithms based sa definition natin ng logarithmic function. And then naturally, we'll sketch yung graph niya and then we'll use the sketch to describe yung properties and behavior ng isang logarithmic function. Dahil nakadikit yung konsepto ng logarithmic function sa exponential bilang siya ay inverse ng exponential function, balikan lang natin saglit yung exponential function. So the exponential function has the form y equals b raised to x, yung variable natin, yung exponent. And we have rules kung ano yung pwedeng values ng b, yung base. So b has to be a real number, it has to be positive, and hindi siya pwedeng equal to 1. And we have two scenarios. First is if b is greater than 1. Yung graph nung exponential function na yun will look like this one on the left. And if b is between 0 and 1, yung graph niya ay decreasing, similar to this one on the right. Nakita din natin last time na yung mga exponential functions of the form b raised to x that follow this restriction, dumadaan sila lahat sa 0, 1 at horizontal asymptote nila lahat yung x-axis. But if b is greater than 1, it's increasing. And if b is between 0 and 1, it's decreasing. Now, we want to talk about the inverse of the exponential function. Kasi yun talaga yung pupuntahan natin eh. So let's say we have y equals b raised to x. And to find yung inverse niya, ang ginagawa natin ay ini-interchange natin yung variables. Yung y gagawin nating x, yung x gagawin nating y. Like so. And then yung next step ay i-isolate natin yung y. Y equals something. How do we do that here? Wala pa tayong rule kung paano natin ibababa yung variable na nasa exponent. So in the absence of such a rule, define tayong bago. And yun yung logarithm. It is the way natin na i-isolate yung variable na nasa exponent. So ang gagawin na lang natin is if x is equal to b raised to y at hindi natin mabababa yung y, edi i-define natin si y using a new term, which is yung logarithm. So, if x is equal to b raised to y, this is equivalent. This is a symbol for equivalence. Yung double arrow siya kasi dalawa yung lines, then double yung heads niya. We will write this as y equals log or logarithm base b, yung pa rin yung tawag, it's still the base of x. So again, x equals b raised to y, this is equivalent to y equals the logarithm base b of x. Siyempre, yung same restrictions for b will apply. B is a real number, b is positive, and b is not equal to 1. Kasi inverses sila, and yung b, yun yung base nila in common ng exponential and logarithm. These two expressions are equivalent. They mean the same thing. Okay, so the logarithm function is pag ginawa na nating f of x yung y. So f of x equals log base b of x. Same restrictions ng b. B is positive, b is not equal to 1. Ang basa natin sa kanya ay the logarithm of x with base b, or yung ginagamit ko kanina, logarithm base b of x. Practicein natin, no, yung form niya. Kasi before tayo mag-proceed sa logarithm, maganda meron tayong working idea of what it's asking from us. And essentially, yung tinatanong sa atin na y, sinasagot ni y yung question niya, what exponent should we raise b to get x? So here, the base is b. Ano yung exponent na magiging 3 raised to that exponent will give us 81? Or 3 raised to what is 81? Yun yung tinatanong ng expression na to. So, 2 seconds. Ano yung sagot? Ano yung number na pag ni-raise natin si 3 doon, we'll get 81? So, we have 3 times 3 is 9, times 3 is 27, times 3 is 81. So, 3 raised to 4 is 81. The logarithm base 3 of 81 is 4. Sulat natin. 4. Okay. Next example. The logarithm base 4 of 1 over 16. Saan mo i-raise si 4 para makakuha ka ng 1 over 16? Pwede ba yun? Siyempre pwede yun. Alam natin na 4 squared is 16. Pero yung sagot dito, 1 over 16 eh. So how do you go from 16 to 1 over 16? You take the reciprocal. And taking the reciprocal, pareho siya sa raising to negative 1. So kung 16 raised to negative 1 will give us 1 over 16. And 4 squared is 16. And the 4 squared raised to negative 1 is 1 over 16. But 4 squared raised to negative 1 is 4 raised to negative 2. Negative 2, yung exponent na kailangan natin i-raise si 4 para makuha natin yung 1 over 16. So the logarithm of 1 over 16 base 4 is equal to negative 2. What is the logarithm of 1 million base 10 or log base 10 of 1 million? You might have noticed that your calculators have a log button. And minsan, hindi ka pwede mag-specify ng base. Maybe for older calculators. I think yung newer calculators, pwede ka na mag-specify ng base agad eh. But, meron tayong convention na if hindi natin i-specify yung base, so nakasulat lang, log of 1 million, it is understood that the base is equal to 10. So again, log base 10 of 1 million, this is the same as log of 1 million. Pag hindi binigay yung base, it's understood to be 10. So anong exponent natin i-raise yung base natin na 10 para makuha yung 1 million? Well, we could just count the zeros. We have 6 zeros. So 10 raised to 6 is 1 million. So this expression is equal to 6. 10 raised to 6 is 1 million. So log of 1 million base 10 is equal to 6. So hopefully those 3 examples are sufficient no, para makuha natin yung interchange ng exponents and logarithms. They're the same thing at their core, but the logarithm allows us to approach yung exponent from a different direction. Now, based on that definition, and keeping in mind that the logarithm is an exponent, let's look at these 4 basic properties of logarithms. So first, log base b of 1 is equal to what? Understood na yung b natin is a legit value. So it's positive and it's not equal to 1. So log base b of 1, anong exponent natin i-raise si b para makuha si 1? So that's clearly 0. Log base b of b, second property. Log base b of b. So anong number natin i-raise si b para makuha natin yung b? Ulit. That's clearly 1. b raised to the first power will give us b again. Okay, these two things are equivalent. So let's start on the left one. Log base b of b raised to x is equal to what? Saan natin i-raise si base b para ang makuha nating value ay b raised to x? So that's clearly x. So b raised to x is equal to b raised to x. Remember na sinabi natin na ang logarithm ay inverse ng exponentiation. This part is an exponential function. Then, kinuha natin yung logarithm niya. Inverse ang logarithm ng exponentiation. So, naturally, if you evaluate f of f inverse, you'll get x again. So, this is expected dapat. Baliktarin naman natin. b raised to log base b of x. Equal to saan? Again, logarithm, pinasok natin sa isang exponential function. F of f inverse will give us x kasi inverses nga yung dalawa. Now, aside from the inverses sila na argument, i-analyze natin siya from how we look at the logarithm. The logarithm is the exponent na i-raise natin si b para makuha si x. So, this is the number na pag ni-raise natin si b, makukuha natin si x. Eh, this is the number na pag ni-raise natin si b, makukuha natin ay di si x pa rin. So, we could look at it as they are inverses, but we could also look at it from the definition of the logarithm. Kasi the logarithm is an exponent. Balikan nyo na lang itong part na to kung medyo magulo yung explanation na yan. Okay, so let's graph logarithmic functions. Now, normally, when we graph functions, pwede tayo mag-plot ng point by point. So, we'll get values from 0, 1, 2, 3, 4, 5, 6, and so on. And ipa-plot natin siya. But the thing is, it's a bit difficult to do that sa logarithmic functions. So we'll take advantage of the fact that it is the inverse of the exponential function. We'll still do point-by-point plotting. So, for example, let's plot f of x equals log base 2 of x. So, this is 2 raised to y equals x. Pag pinagpalit natin yung x and y sa exponential. So, we know that y equals log base 2 of x, saka x equals 2 raised to y, they're the same thing written in different ways. Parang x equals and y equals, but they are the same equation. They are equivalent. We already know how to plot an exponential function, so dun tayo mag-start. I have an x and y, pero dun muna ako sa y, dadayain ko, dun ako sa y maglalagay ng values. Kasi it's easier to get x values than y values. Kasi it's easier to raise a number to an exponent rather than to take the logarithm of a number. So I'm taking values from negative 4 to 4, and 2 raised to negative 4 is 1 over 16, and so on and so forth. These are the same values na ginamit ko dun sa last lesson natin. And then I will plot these points. Diretso ko na, hindi na pa isa-isa. So this is 1 over 16 negative 4, 1/8 negative 3, 1/4 negative 2, and so on until 4/2. So nag-stop na ako sa 4/2. Sorry, hindi ko na tinuloy na hanggang 16. And connecting the dots, then this is the graph of the logarithmic function. Comparing it with the one na nauna nating na-discuss, yung exponential function. So this is the graph of an exponential function where b is greater than 1. Pag finlip natin siya along the diagonal y equals x, then we'll get our graph of a logarithmic function. And if kung yung base naman natin ay between 0 and 1 sa exponential, consequently, ito yung impact niya dun sa ating logarithmic function. Hindi sila pareho mukha lang pareho. Dito, yung x-axis, yung horizontal asymptote. Dito, yung y-axis, yung asymptote. It's now a vertical asymptote. Notice that for the case na parehong b is greater than 1, if the exponential function is increasing, the logarithmic function is also increasing. Kahit mukhang nagpa-flatten yan, hindi yan magpa-flatten. That just goes on and on. Pataas. Babagal lang yung pagtaas niya, pero increasing siya. If your exponential function is decreasing, yung inverse niya na log function is decreasing as well. Note that this one, hindi siya magpa-flatten. Tuloy-tuloy lang yan sa pagbaba. Mabagal lang na mabagal yung pagbaba niya. Now, looking at these two logarithmic functions, we could more or less makita natin tong properties na to. That one, the domain is the set of positive real numbers. Hindi siya pwedeng maging 0. The range is the set of real numbers. Kahit mabagal yung pag-increase niya, papataas at papataas pa din siya. The graph is continuous, wala siyang butas, and it will pass the horizontal line test. It is 1-to-1. The x-intercept of any logarithmic function is 1 unless you perform a transformation on it, like a translation or a reflection. It has no y-intercept kasi asymptotic siya sa y-axis. Again, unless you translate or reflect or scale. It has a vertical asymptote at the y-axis, x equals 0. Now, daanan lang natin to mabilis. If you recall from last meeting, meron tayong dinefine na special exponential function na tinawag nating the natural exponential function, where y is equal to e raised to x, where our base is e, Euler's number, which is approximately 2.71828188, ... and so on. And its graph will be between 2 raised to x and 3 raised to x. So if we take the inverse of the natural exponential function, we'll get the natural logarithmic function. And as with the natural exponential, it is between log base 2 of x and log base 3 of x. Now, if you recall, last lesson, nung diniscuss natin yung exponential function, sinabi natin na yung nagpapaspecial sa kanya ay yung slope nung tangent line sa points ng isang exponential function. Pag kinuha natin yung slope, equal siya dun sa y value nung function na yon. Kung di maalala, maaring balikan yung video from last lesson. For the natural log function, meron din siyang ganung klaseng special relationship. And let me open my GeoGebra para ma-discuss ko yung relationship na yun. Okay, so before I proceed, i-discuss ko lang kung ano yung meron sa screen. Itong parang reddish brown na graph, this is the graph of the natural logarithm function. This is log of x base e, where e is approximately 2.71828, which is Euler's number. Then I have a slider a. Yung slider na yan, siya yung nagkocontrol ng posisyon ng point capital A. Ang coordinates ni point capital A ay yung kung ano man yung x ng slider, tsaka ln of A. So, A, ln of A, kasi f is ln. Next, I have a second function, g of x. It's 1 over x, yung ating basic rational function, yung parent rational function. Hindi ko siya gagraph, nakapatay siya. But take note that I have a slope equal to yung 1 over x evaluated at a. So, right now, a is equal to 1, so 1 over 1 is 1. I have a slope of 1. At pag nag-drawing ako ng tangent line passing through point A dun sa curve ko, ang slope niya ay equal sa 1 over x. So, ito yung special sa natural logarithmic function. Actually, isa sa mga special na bagay sa natural logarithmic function. If we draw a tangent line to a point on the curve of y equals ln of x, yung slope nung tangent line na yon, so kunyari, lalagay natin sa a equals 0.2. Yung slope nung tangent line sa point na 0.2 ln of 0.2 ay equal sa 1 over 0.2 or 5. Pag nagpunta naman ako sa, kunyari, sa 5, so at a equals 5, my point is 5 and ln of 5. 5 and approximately 1.61. Yung slope ng green na tangent line to this point on the curve, it's 1 over 5. So maybe, no, parang, ano ngayon? Ano yung special sa property na to at this point? Well, sa ngayon, sa grade 9, wala pa. But when you start to talk about this in grade 11 or grade 12, then baka lang sana may slightly makaalala na nag-make tayo ng very small connection between the slope of the tangent line on the curve of the natural logarithmic function and the log function. And that it is 1 over x. But for now, maybe hindi pa siya sobrang big deal, but it will sort of become a big deal as you progress sa calculus. So, recap ko yung actually diniscuss ko today. Well, first we define kung ano yung logarithm. It's the inverse operation of exponentiation. So, that's logarithm as an operation. And the logarithmic function is the inverse of the exponential function. Yung if you flip natin yung x and y variables, if you flip natin yung coordinates na x and y pag pinaplot siya, at we flip natin sa line na y equals x yung graph. And the properties of logarithms, yung log base b of 1 is 0, log base b of b is 1, b raised to log base b of x is x, and log base b of b raised to x is x. They follow from recognizing that the logarithm is an exponent. Next, when we sketch the graph of the logarithmic function, kita natin yung domain and range niya will follow from the range and domain, yung kabaliktaran, nung exponential function. And lastly, we define the natural logarithmic function as a logarithmic function na may base e. E is Euler's number. It's approximately 2.718281828 ... And it is the value of 1 plus 1 over n raised to n pag tinaas mo yung n na papataas to infinity. Now, ano yung hindi natin diniscuss? Hindi natin diniscuss, no, yung translations, mirror reflections, and scaling ng log functions because the rules for the transformations of the log function are the same as the ones that we used in the previous functions. So, paano mag-translate to the right? X minus h. Paano mag-translate downwards? We subtract k from the function value. Paano yung mirror reflection? Pag ninegate natin yung function, mag-flip siya along the x-axis. Pag ninegate natin si x, mag-flip siya along the y-axis. Scaling, if we multiply our function by a, then all the y values get multiplied by a. These follow the same rules as the exponential functions, so I will not use up time anymore discussing them. But they follow the same rules. And in the exercises and in the exam, you'll probably be asked to perform some transformations on logarithmic functions. So thank you very much and see you sa next video.